Alright guys, we got a little review on force diagrams with friction. Start here with the block on the block problem. We got 3 on top of a 7. Also tells us a little something about the surface, 0.7 and 0.4. What forces needed to make the blocks move? So the first thing we want to do is combine their masses and make it into 10. And we have weight, which would be 98, normal force, which is 98. Then we can use this to find the friction. So F of Fs equals mu s times the force of normal. Put 98 in for the force of normal. Mu s is 0.7. And we can calculate what static friction would be. So we're going to use 0.7 times 98. It gives us 68.6 for FFS. 68.6. So as long as we have a force that's greater than 68.6 newtons, it will move. So that's the first question. Will it move is static. Then it says what force is needed to give the blocks an acceleration of 1.5. So to do this, what we do is we go back to the same thing we just had. 98 and 98. And this time we want to find the kinetic friction. So we say FFK equals mu k times the force of normal. So mu k being 0.4 times 98. So we go back and we do the same thing we did before, except we make it 0.4. 39.2 would be the friction. But that's not the question. The question is what force is needed to give it an acceleration of 1.5. So we do our x summation and we say FFK minus, or scratch that, start over here. So we say this unknown force, which is called FP minus FFK equals MA. And we know some of these things. We know that FFK is 39.2. We just have to figure out how much FP needs to be in order to get 10 times 1.5 or 15. So something minus 39.2 is 15. So we can just simply say 39.2 plus 15, and we get 54.2. So if FP is 54.2, it will have an acceleration of 1.5 meters per second squared. So that's what force, 54.2 Newton. Minimum roughness between blocks for the top block to stay on. So now what we want to do is we want to focus just on the top block. So we got a 3. We'd like to know what mu s needs to be in order for it to stay on. So 29.4 would be here, 29.4 would be here, and then it's accelerating at 1.5. I don't know how well I made that known, but it's accelerating at 1.5 to the right in the direction it's being pulled. And the friction is actually to the right as well, which is kind of surprising, but remember it's like the floor is moving underneath it or the block is moving to the right. Even though the acceleration is the right, so is the static friction. So we say sum of forces in the x, that would be FFS equals MA. We have 1.5 and 3, so that would be 4.5, and that equals the mu s times the force of normal. Well, the force of normal here is 29.4, so then that allows us to calculate mu s. Mu s has to be greater than or equal to 4.5 divided by 29.4. It's a pretty small number. 4.5 divided by 29.4 is 0.15. So it has to be greater than or equal to 0.15. So I come up here and I write 0.15. If the boundary between the block was 0.4, will the top block fall off? So the minimum is 0.15. If it is 0.4, it will stay on because it's rough enough. Remember, this is a minimum roughness. 0.4 is greater than 0.15, so it stays on. That's the first part. Coming back here.